Hello, in this short video I'm going to solve the following problem. Let S be a set of cardinality n. How many binary operations star can one define on S such that x star x equals x for all x in S? Pause the video at this point and give it a try. Okay, so let us consider that this is the set S with cardinality n elements in it. I want to define a binary operation that respects the condition given in the problem, yes? So what is a binary operation? A binary operation star is a function from the Cartesian product of S by itself into S, which assigns to every ordered pair in this set exactly one element from the set. So, in other words, if you want to visualize it in a little bit better way, it means that when you want to define a binary operation, you can consider an n by n square and start filling up each square by any element that you choose from S. You don't have any constraints. As far as you just want to define a binary operation, you do not have any constraints. So any one of these elements can be chosen for one of any square that you see here. Okay? But now I have to respect another condition. So I have one constraint, and the constraint is that for all x in S, x star x should be x itself. So for example, before having this constraint, I have n options to fill up this first square. But now, because of this constraint, a1 star a1 has to be a1 if I want to respect the condition. So I have only one option to fill it up, and that is just a1. So this 1 means the number of options that is available to me when I want to fill up this square. With the same reasoning, there is only one option available for me to fill up this, because this is a2 star a2. According to the constraint, it should be a2. So I have only one option. I have to fill it up with a2. And this will continue. So every diagonal, on every diagonal, I have one option left until the very end. But the remaining squares in this table can be filled up with any one of these n elements without any extra constraints. So this means that if I ask you how many options are available to fill it up, a1 star a2 in principle can be any one of them. Okay? So this means that I have n options available here. So the remaining squares, every one of the remaining squares has n options. So this becomes n, n, I don't know, n, all of them are n. But if I ask you what is the total number of options I have to multiply these numbers inside this table, inside this square. So if I multiply ones, of course the answer is 1, so they are not important. The only thing important for me is these n's and see how many of them are there, but that's extremely simple. So the question mark is n times n times n up to n, but how many n's are there? In total, I have a square with n rows and n columns, so the size becomes n squared, but n of them sitting on the diagonal are just 1. So how much is left, how many of them are left is just n squared minus n. So if I ask you how many n's you see in this table, you will tell me n squared minus n. Okay, so I am multiplying a number by itself this number of times. That is the definition of power, of course. So this becomes n to the power of n squared minus n. And that is the answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.